Hey everyone, this is just a rundown of the incline plane free body diagram. Notes there's not any examples in this video, so look for a separate video with one of those if that's what you're needing. Alright, so an incline plane free body diagram is going to start off kind of looking like this. You're either going to have an object that's sitting on it or moving along the ramp, and if it's moving, it could be moving with a constant velocity or moving with acceleration. First off, we're going to have our force of gravity, of course, and then we're going to have a normal force. The force of gravity is going to go straight down, right? Just like it would on any other free body diagram. But your normal force is going to go perpendicular to the surface of your inclined plane. So it's not going to go completely opposite of your force of gravity. So that's different than what we've been doing so far. So it's going to look something like this we see here. Right. To determine the value of your normal force, we have to first break down our gravity into two separate components. So going back to our vector unit of component vectors, that's essentially what we're doing here. So we're going to call these a perpendicular force and our parallel force. Right? You might see some different terminology out there for these forces, but this is what I go with. All right. So we're breaking down our force of gravity that technically we could consider that a resultant vector, if you will. And perpendicular and parallel forces are two component vectors of that. So our perpendicular force is going to be opposite of our normal force. And then our parallel force is going to run parallel to the surface. And it's what I say is down the ramp or down the inclined plane. So here we have our normal force and our force of gravity drawn like we had on the last slide. Our perpendicular force is going to go down into the ramp opposite of that normal force. So if this were like a normal free body diagram that's not tilted on its side, that's where force of gravity kind of typically would be. And then if your parallel force there is in red going down the ramp. All right. To calculate this parallel force, we are going to use sine and cosine in these parallel and perpendicular forces. So our parallel force, you're going to use the formula parallel force equals force of gravity sine theta. And then for your perpendicular force, you're going to use force of gravity cosine theta. And remember, you do want to be in degree mode on your calculator. So just to recap everything that's on your diagram so far, we've got here labeled. All right. Once you break down these parallel and perpendicular forces, you're not technically really using that force of gravity again because you've broken it down into those two component vectors. All right, I will have you label them on a test though, all 5 things. So your normal force, then we now can figure it out because we have our perpendicular force. That's going to equal the perpendicular force. So normal force is going to be the same as perpendicular. And then we're going to have a friction force involved, and that's going to go opposite or up the ramp. All right, so this friction force is going to equal the parallel force if our object is either at rest or if it's moving at a constant velocity. And to go back to the beginning of this unit, they're going to be equal because we'd have a net force. That would create a net force of 0. And with a net force of 0, you either have to be at rest or moving at a constant velocity. And then if our object were accelerating, they would not be equal. And in order to solve the problem, you would need more information, such as your net force on the object, or I could give you the coefficient of friction in order to continue to solve that problem. All right. Most of the problems we're going to work with, they're going to be a simplified one where it's at rest or it's moving at a constant velocity, because I'm just trying to get you guys to understand the basics of these. All right. So this is just a breakdown of everything on here and go through your notes. I'll post a separate video of working out an example, and you'll probably see some videos from your study guide on here as well of these problems for you to go through. All right. Please let me know if you guys have any questions, and I'll see you in class.